Welcome to Unit 5, Lesson 3, Understanding Rational Inputs. So, one thing we got to understand, when we see the word rational, what does rational mean? It means fraction. So now we are going to be dealing with fractional inputs. That means our exponent, because in exponential equations, our variable is an exponent. So we're going to be dealing with fractions up here. Okay, again, exponential functions. B bigger than 1, you have growth. If B is bigger than 0 but less than 1, you have decay. All right, keeping equations true. Select all equations to x times x equals 5. X times x equals x squared. If x squared equals 5, we can't leave a solution with x squared, so we have to take the square root of both sides. So x is equal to the square root of 5, positive and negative. But also, we have to change this radical into a rational function. And if you forgot, mathematicians are lazy. They don't write like in ones for exponents or coefficients. And it's understood that when you have a square root, the index is 2. So we have to remember back to the beginning of Unit 3, where the exponent was the numerator and the index on the root was the denominator. So this means 5 to the 1/2 power. The square root of 5 is the same as saying 5 to the 1/2 power. The base stays the same. So B is a good answer and D is a good answer. Okay, now we have P times P times P, which means P cubed equals 10. To solve an equation, the coefficient, the number in front must be 1. The exponent must be 1. So we take the cube root this time. So the cube root is indicated by a 3 as an index. So P, 1P cubed, the cube root of 1P cubed is P, gives us the cube root of 10. 10 has an exponent even though it's not written, which is 1. So this also equals 10 because the base stays the base to the 1/3. So A works and E works. B, this is the square root, not the cube root. B does not work. Okay, let's look at what Jada do. Jada has a base population of 54,500 in the year 2240. So this is our start year. And then we get per decade. So now X equals decade. This is why you have to decode what the words are telling you when you have a problem. 60% is not our growth rate. We know it grows. 54,500 equals 100%. Our A, 54,500 is our A. That's 100% in 2240. Okay, so we get 100% plus 60% because that's our growth percentage. Give us a growth factor of 160%. We're going to divide this by 100 to get 1.6. This is our B. So now let's write our equation. The first thing we do is write our equation. I don't know. Let's just write Y. I'm not going to worry about function notation. I should probably write all of these in function notation, but I'm not going to do it. 1.6 to the X, where X stands for decade. Understand that. This is why you have to look at the words. And see, look, per in this one. Per, each, and every are interchangeable. Whenever you see per, each, and every, that is going to be your rate in a linear equation, but an exponential is going to go next to your B. So now let's look at the questions. Okay, since we put y equals We push that button. We put 54,500 to the 1.6 to the x. We put that into the calculator. At 0, when x is 0, you get 54,500. When you get 1, so 1 stands for 1 decade. So when x equals 1, that's 1 decade. 10 years from 2240, what is y? Y equals what? And when x equals 2, which is 2 decades or 20 years from 2240, we get 2260. Y equals what? Let me put it into the calculator and write the numbers down. Now see how they come and ask you what the function is after? All right, I'm going to change this to function notation after I calculate the numbers for 2. So in 10 years, it was 87,200. And 20 years is 139,520. 139,520. 139,520. 20 whatever population. People, I guess. I don't know. Now, write the function in function notation. So we're going to write f as a function of decades is 54,500 to the 1.6 to the d, where d stands for decades. Now, what does f of 5 mean? 0.5 times a decade, which is 10 years, gives us 5 years. 0.5 also equals 1/2 as a fraction. So this is 5 years. So what I'm going to want to do is I'm going to predict, because they're going to do some funky things in the next question. So the first thing I'm going to do is, if a decade is 10 years, I should probably not calculate 5 years, because they're probably going to ask me every year. So probably what I should do is find 1 year. So if a decade is 10 years, if I divide by 10, if I take my x and divide it by 10, that will give me 1 year. Because a decade is 10 years. If I divide it by 10, I get 1 year. I'm going to use this as an exponent. So B, we're not going to worry about graphing right now. So f of 0.5 is the same as 1.6, our factor. 1.6 to the d was our factor, right? D stood for decade, which was actually 10 years. But if you take the square root, that's the same as saying 1.6 to the 1/2 times d, or 1.6 to the d over 2, which is the same as a half. But we don't want that. We're going to use 1 year. So we're going to use 1.6 to the d over 10, so we can calculate any 1 year, because they're not just going to ask us what this is at 5 years. So I have to go back to y equals. I have to amend my thing by scrolling over and hitting divided by 10, and then going back second graph. And in 5 years, my population is 66,938. Oh, 68. I'm sorry. I'm getting old. I'm getting blind over here. 68,938. That's my population. So let's see what questions they're going to ask in the future. All right, see, look at this. 2258. So if we started in 2240, how long from 2258 to 2240? That's 18 years. Since I've already converted my equation into 10 years, into 1 year, from 10 years to 1 year, all I got to do is find when x equals 18. So if I scroll down to 18, y equals 127,002.5. That rounds off to 0.03. Because you can't have half a person. So 127,002.55880. We just used 127,003. So when you have amounts that are whole and they're asking you for fractional inputs, change your unit all the way down to as low as you can go. So if it's like asking you for hours, change it all the way down to minutes. You might have to divide by 60 or whatever. Some low unit of time, because they can ask you anything. They could have asked me about a month, and I would have had to divide by, 12. 10 times 12. I'd had to divide by 120 to get down to 1 month. Okay, so let's look at this one. We have no numbers in our story. So now we're strictly on the graph. So when x is 0, y is 12. When x is 1, that's point. All right, at least we got a whole jump here. We got a whole jump, which is great. So 0.75 divided by 12, because why? We multiply going right, which means we have to divide going left. So in PEMDAS, addition and subtraction and multiplication are equal. It depends on which comes first, but they're equal in the opposite. So the opposite of multiplication is division, and this is why we do this. So this will give us our B, which is 0.0625. That number is messy, so we're going to, in a calculator, hit the math button, which is under your green alpha button. Hit math, enter, and this will give you 1/16. Now, this is the easier number to deal with. Now that we know the B, and our time is 1 hour, so x equals 1 hour, that's important to write down, we get 12 times 1/16. So the value of it is 1/16 of the original amount after 1 hour. Now let's see what they're going to come at with us. Okay, use the graph to estimate 1/3 and explain what it tells us. 1/3. Well, if x equals 1 hour, which is 60 minutes, one-third of an hour is 60 divided by 3, which is 20 minutes. So we could go by 1/3. All right. After 1 hour, find an equation that defines. We already wrote our equation. F of t, t stands for time, is 12 times 1/16 to the t power, but we're going to use x in the calculator. All right, let's just go with this. Let's just go with 12 times 1/16 to the x over 3. So this is going to give us every 20 minutes, but I have a feeling I'm going to have to change it. So I'm going to put this in the y equals. And remember, these divisions represent 20 minutes. So when you hit y equals and you clear it out and you do 12 parenthesis 1 divided by 16, close it, caret x, second graph. So, wait, I forgot to divide by 3. That might help. Divide by 3. When I get at 1, it's about, so when x is 1, which means 20 minutes because I divided by 3, y is about 4.76. So if I go to my graph and I put 4.76, we'll get right. This t represents 1 hour, and this equals 1 hour. But I had to change my input based on what the question was asking me.